If you're watching this video, then you are either a mathematics teacher or you're willing to become a mathematics teacher, or maybe you're thinking that shall I take up teaching in mathematics as my career? Now, you are all great mathematics teacher. You have great love and affection from your students. You teach great mathematics from grad or undergrad level. But in this video, what I'm going to do is that throw some more light, give you certain techniques and approaches which will eventually help you more into teaching mathematics to your students, and you will get more love, more affection, and a kind of a different approach which will make or shape your career in mathematics in a better and a brighter prospective future. My name is Shaunak and you're watching this video on my channel Physics for Students. I welcome you to watch this video. Before I start and go ahead, just a kind of a note to all the teachers who are watching this video. This video is not meant to undermine your capacities or not to tell you that whatever you are doing, this is right, this is wrong, or you should not do that. But it is rather a way through research, analysis, talking to my college, university, professors, lecturers, and even today where I am connected to different great professors in Rochester and IIS and other universities, what could be the best practice, what could be the best way in which you can improve your teaching methods, techniques and skills. So just to note, this is not to undermine you, but rather I would say to bring you to the juncture where the teaching of mathematics is even more better. Okay, this is the first point. A good mathematics teacher is the one who was an average student. Now, what I'm trying to tell you is that it is not that in order to become a mathematics teacher, you need to have brilliant scores in mathematics. You have to be an outstanding scholar and an academician, that starting from your school days to your grad and college and university days, you have scored all 100 out of 100. It is not that. Why? I will tell you the reason. Would it have been that you are absolutely excellent, you're getting all 100 out of 100 in throughout your career? That means that when you're coming to teaching, you do not know the pain that a student will suffer. Now, if you would have been an average student, say for example scoring around 40, 45 or 60, 65 marks overall in your career in mathematics, then it is quite understood that you really know those areas which the students are lacking. Maybe those 30 or 40% which the students really don't know. Now, don't take me wrong. I'm not saying that brilliant mathematicians are brilliant teachers, but as a matter of fact, I have seen in my life, brilliant mathematicians cannot be brilliant teachers. Rather, a person who has not got a very good score or has been, kind of an average throughout his career has been a better teacher. Because in those days when you are struggling through mathematics, in order to score a very good marks, you really understand the struggle. You really can understand where the students might fail. You really understand that these are the areas which are pain areas, which are areas which students need to concentrate more and more and more and more. So I mean to say, logically it is quite understood that always great scholars are not always great teachers. Great scholars are great scholars. Yeah, I mean to say they are great scholars, but it's not evidently that a great scholar will eventually be a very good teacher. In order to be a teacher, the first thing that you have to keep it in mind is that what are the pain areas, what are the struggles that your students will suffer. And that struggle or the suffering part will only become evident if you have really suffered. Right. I mean to say, if you have not brushed your shoe with your own hand, you really don't know which part to shine, which part to put a little bit of, that part of the black color, etc. So those teachers who have got a struggling part, who have really struggled in certain part of their career, I would say eventually become a more teacher. Because as a teacher, you do not have to be a great mathematician or academician. You need to identify those areas which your students really suffer. Second part comes very clear from the first part. You should understand the pain of the students. Now, there are certain teachers I have also encountered in my school and college days. They say, oh, you don't know. Aha, come on. You really don't know how to answer this. Or it is such a silly mistake. Come on. You really don't know what is the value of sine theta or sine so and so. Now, this is the problem. Now, I am coming to you because I really want to learn. Now, if you assume that I will know certain things, then what you are for, right? So, you should understand the pain of the teacher. There are two types of teachers I have seen. One, which I spoke, that those are great mathematicians. They will assume you know a lot of things, and there are assumptions that you know grade 1, grade 2, grade 3, grade 4, and that is why you have come to me. I will just teach you all those skills which you need. And there are teachers who will say, okay, my dear, you really don't know. Not a problem. Come with me. I will teach you. And that is the basic virtue of a teacher. You should understand the pain of the students, and you should be able to teach that pain to overcome, not to show your 100 out of 100 in Cambridge or Calcutta University or Presidency University. We all know that you are a great mathematician, so what? You cannot be a great teacher until and unless you understand the pain of the students. So second point, please keep it in mind that you are only a great teacher when you understand the pain, and you will be able to give certain techniques and tricks so that the student can get out of that pain. Now this part I really don't need to explain much. Should have an inherent capacity to explain concepts in a simple manner. You remember Richard Feynman once told that you really can understand physics or mathematics if you can explain it to a 3-year-old child. Now you can a Nobel laureate, you won Abel Prize, you have won Fields Medal, you have stood first in Cambridge, hardly matters. As a teacher, you should have the inherent capacity to teach. You see, when Professor Leonard Susskind teaches over the Stanford lectures, he's such a great teacher. Such a fabulous teacher. You fall in love listening to his lecture. Why? Because he has got an inherent capacity. Internally there is a capacity through which you can teach, and that is something nobody can teach you. I mean to say, I cannot teach you that how to teach. It is an inherent capacity, a charisma, a kind of I would say a personality. When somebody comes, okay, sir is here. So you have got that kind of an inherent capacity to teach. And in order to do that, I just showed you that you don't need to be a Nobel laureate or a great mathematician. Rather, an average student who knows the pain of the students can really teach better mathematics than a person who has scored 100 out of 100 throughout his career. Need not to be a great mathematician. So always remember that you are, as a teacher, why we go to the doctor. Now I've got a pain in my stomach, I've got a headache. So I will go to the doctor in order to cure my headache or my stomach pain, right? Now if the doctor is FRCS coming from England or France, etc., I mean to say, will it really matter if a doctor gives you a medicine and you are okay with your headache and your stomach ache? Does it really matter? Tell me. That you go to a doctor, if it is not a surgery case, and who takes a fee of maybe say $20 for just a small medicine to cure your headache because he has an FRCS, come on. Right, and you go to a doctor who takes just a little bit of money and he can cure your headache. So how does it matter? So for a student, remember, a teacher is only great when you can just give the right medicine in order to overcome that, and in a simple manner, so that that particular formula can be reiterated one after another and the student can overcome that problem. This is something very, very interesting. Most of the mathematics class starts with an answer. Okay, hi, my name is Bob, and today we will be reading trigonometry. So point number 1, formula 2, formula 3, and a huge lot of formulas are given, formulae are given to you. You have to remember them, and the professor will ask you, now let us solve the question. I would say no, that is a wrong approach. You should start a question rather than with an answer. Say for example, any type of question, you come to a mathematics class and you must ask, okay students, my name is Bob. So today we all know that we will be learning linear algebra, but why will we learn algebra? Why will we learn mathematics? Why will we learn mathematics at all? Why don't we learn political science or history or geography? There you plant the seed of questioning to a student. So rather than giving a direct answer, so this is Pythagoras' theorem, this is how fractions come, this is how decimals come, ask them why we need a decimal system, why do we need a fraction, why do we need a trigonometry, why do we need a linear algebra. So mathematics, by all the mathematicians including India and Greece, they have been invented to solve a problem, right? So what is that problem? If there is no problem, mathematics would not have existed. So I would strongly suggest that start your class with a question. If it is an algebra, let us say that why do we need algebra? Things are great, right, with mathematics. We do arithmetic progression, geometric progression, all those formulas are there in mathematics. Why do we need algebra? Why do we need to assign a variable at all? Right? So you show them a bunch of oranges, right? And then you say that, okay, these bunch of oranges, orange 1, orange 2, orange 3, orange 4, we cannot write them. So we assign a variable x to a bunch of oranges. And then you take a bunch of banana and you tell that these bunch of banana are assigned a variable y. So now we will compute between 1 orange plus 1 banana, addition, multiplication, subtraction, whatever, and we always don't have to say that 1 orange plus 1 banana would be equal to, so we just say x plus y equals to this, or x1 plus y1 equals to this. Until you inculcate the need of a variable within the student, it will always be, oh, x and y, again a mathematics, again a sums, again a problem. Why we need x and y? Why we need x squared and why not x cubed when the exponentials are required? Anyway, it would take a long time to explain those, but for grad students, college, school going, undergrad, my serious recommendation to you would be, please start the class with a question rather than an answer, because only when a student will understand the need for mathematics, the need for algebra, the need for trigonometry, then only mathematics will become easier, and then only you as a teacher will become a success. We know mathematics require time. If you see my earlier videos, that mathematics is just like bodybuilding. You cannot do 20 crunches or 100 crunches in a day and you become a Mr. World and you say, oh, all my belly fat has gone. So you need time and time and time and time. 6 months, 1 year, 2 year, 3 year dedication. Same goes with mathematics. That is why I have given this point. Give the students time to struggle. Now you might say we have to complete the curriculum, there is a board syllabus, we all understand. But still you can give the students a time to struggle. Mathematics is a game of struggle. Mathematics is a game of doing more, and please do give students the time to struggle. If you rush upon, if you force them upon, if you give them ready-made formulas, they are never going to learn. Believe me, it is not my experience. It has been told by many professors and teachers. Today I am telling you with claim, give the students time to struggle. Give them a kind of a game, right? So when you give them a game, what they do, say for example, they will hide upon the pillars, they will go under the roof, under the cot, etc. Why? They are playing a game. And games require a time. Even computer games require a time, right? So you as a teacher, your foremost duty is not to thrust upon the student with formulas. Give them time to struggle. Give them time to think. If they're not thinking, they are not coming up with a solution. What they are doing is that just they are mugging up things to score good things in examination. I remember in my school and college days when the teachers used to throw upon a problem and tell that, okay, class, say for example, class 6, say for example, class 7. Class 7, you are given this problem and you have 2 days to solve it and I will wait for your answer. Then we say, hey, come on, can we solve this? We get in groups. I am asking to my friend, she is asking to me, and we finally come up, ma'am, can we tell you the problem we have solved? Right? So you are giving time to struggle. You are giving time to students to think, and as a teacher, we don't call us teacher, we call nowadays facilitator. So as a teacher or a facilitator, your job is not to solve the problem. Your job is not to make the students pass the examination. Your job is to make the student think and think. You as a teacher will only be successful if you plant the seed of thinking, and after 10 years you see that small plant has bloomed into a full-grown tree which is only thinking in the right direction. You are not the key to answer. This goes not only to teachers but to parents. You sit with your child to solve a problem, and your child as mama or papa, you cannot solve it. Tell me the question, tell me the answer. Now, it is okay that you don't know the answer. As a teacher, it is okay that you don't know the solution. Let us do it in this way. Okay, let us come together and solve the problem. Let us come together and discuss that what could be the problem. So you are not the key to the answer. Come on, as a teacher, as a parent, it is not your duty that you will know everything. But you should engage your child or your student or the family of students into discussion so that math become an adventure. So for example, I am going to the jungles of Africa, right, with my wife, with my child and some of my friends, right, and we will say, okay, we really don't know where the leopard will be jumping, where the anaconda will be there, and where the wild animals will come. Come on, Shaunak, you really don't know Africa? You really don't know where the leopard will come? I will say no. So it is assumed that when you're going to the jungle, we really don't know, because that is an adventure. So mathematics will only become an adventure when you give the time to think and you assume you are not the key to the answer. It is not necessarily that you need to know everything. Now, here is something which will come up eventually. Right, when you are saying that you are not key to the answer, the student might ask and come up with a very, I would say, an original idea which you really don't even know. So they come up with a solution which shows that 1 plus 1 equals to 12. And somehow the algorithm shows it in such a way that you cannot deny. You might find, oh, this shows that 1 plus 1 equals to 12. What will I do? But traditional teaching says 1 plus 1 equals to 2. Right? So remember, I'm coming to the answer. How will you do? So you as a parent, as a teacher, you don't need to know everything in the class, everything in the examination. You should form a kind of an environment where the students would come together, form a group or talk with you to find the answer, and then only mathematics become an adventure. So when your students come up with an idea 1 plus 1 equals to 12, this is what you are going to say. Yes, say yes to the ideas of your students, don't say no. Now if 1 plus 1 equals to 12, let us sit down and see that if 1 plus 1 equals to 12, then 1 plus 2 will be equal to 13 and 1 plus 3 will be equal to 14. Now in this way, if we go, then the entire edifice of mathematics collapse, right? So I would like to say that say yes to the ideas of your students. Don't say no, because an immediate no will create a kind of a gap, create a kind of a mentality that the students won't come to you. Students might come up with some very, very original ideas. Say yes to them. If you see that the ideas are not matching with the rules that we are taught or mathematics obeys that rule, let us sit together and let us find out what could be the solution. But the idea is that please say yes to the ideas of the students. This is wonderful. Do not say the problem is difficult. Say it needs more practice. There's a difference you see. If you say, Shaunak, the problem is very difficult. What will I do? Oh my goodness. Then what will I do? If it comes in examination, will I fail? But rather, if a teacher tells me it needs time to practice, that means it is achievable, but I need to dedicate more time, which is quite obvious because mathematics requires some amount of time. It requires dedication, it requires practice. So I would say, do not say it is a difficult problem, say that it needs more practice. Thereby you are involving the student group or a particular student into practicing more rather than saying difficult, because difficult is a very negative word when the students are learning. You will make the difference easy or difficult subject. All subjects are easy provided the way you are being taught. I will give you a very personal practical example. Again, class starting with my daughter and some other students. So my daughter comes up to me and say, Papa, this part of fraction is very difficult. This part of physics, work done, etc. is very difficult. Why? Because I am not a teacher in my daughter's school. I teach you people, right? So the problem that arises is that when you are teaching something, if you teach it in a very difficult way, that is why I told you that do not say that the problem is difficult, say it requires practice. You are making things easy. You are making things which are pretty easy and normal. So you will make the difference easy or difficult to the subject. When a child or when a student is coming to you, remember, he or she is naive. He or she has got no idea about the subject. You are making the subject difficult. Now, when my daughter comes to me and say that English literature, no problem. Why? So for a child who has got an admission, for him or her, English literature and mathematics are the same thing. Now, if you as a parent have told mathematics, oh my goodness, it is, it's a difficult game, then you are digging the grave of your child. It is the approach which matters. So the concept is that English literature, physics, mathematics, chemistry, history, for a child it is all the same. You as a teacher, you make the difference. Now if you say the problem is difficult, problem is hard, you cannot understand, you know what to do. You are not a successful teacher. So this point is that it is you, that person, who will make a subject very difficult, that students will start running after, they will escape from the problem, and it is you who are making the problem so beautiful that students are loving you, they are loving the subject, and you become a successful teacher. You remember this famous saying, I don't know who was the name of this person, who says that teachers who make physics boring are criminals. Teachers who make physics boring are criminals. Such a huge claim. That means you are a criminal until you make physics easy. Are you getting my point? So it is you who matters, and it is you who are going to create a difference between the good subject and a bad subject. A subject where people will, start escaping your class and they won't go to school because, oh my goodness, so and so ma'am and so teacher is class will make mathematics more difficult. And whether your people or student will start loving you and get a subject which is very, very loving and very, very important to them. This is the last part which I would like to tell. Give them something which internet cannot give. Today, every single solution of every single subject, starting from tying the knot, starting from cooking a pizza, starting from making relationships, starting from yoga, spiritual thinking, every single thing is there on internet. Now, you as a teacher, can you give something that Google or internet cannot give? Mind it, it is very difficult. Because you as a teacher or I as a teacher, whenever we are also making a lesson plan and going to the class, what we are doing? You are going to the net. What you are going? You are consulting the websites. What you are going? You are taking down notes from the internet. So even our learning is, I would say, specified and restricted to one particular domain, that is internet. Now that is not going to help us in the long run. We are mathematics and physics teacher. We are teachers who are going to, I would say, inculcate the critical thinking capacity in the student. And how will a student learn if you consult internet and YouTube videos, etc.? Here I would like to give you the classic example again of my favorite teacher, Professor Leonard Susskind. If you go to the physics and mathematics videos which Professor Susskind makes, starting from the basic classical mechanics, you will see the way he moves around the subject, the way he derives the subject is something which cannot be found on internet. I remember, listening to one of his lectures on general relativity, where he compared the Gauss's law of gravity concerned with that of the classical Newtonian gravity. That means that you need to be absolutely original. Remember that you need to be absolutely original. If you're not an original thinker, then you're not an original teacher. And if you're not an original teacher, then I would say you are not doing any good to the students. Come on. Everything that is there on the internet, everything that is there here on the laptop, everything which Google does, you are just reframing them in your own sentence and you're delivering to the student. My dear teachers, if you're listening to this video, you are creating the future. You are creating a small sapling which will bloom to a beautiful flower and will eventually grow to a complete tree which is going to give shade or which is going to teach other students. So this is not an easy thing to do. I know talking over videos and giving lectures are easy, but give them something which internet cannot give. That means be original, think original, and try to get your notes in such a way that even if they consult internet, they will find no, we cannot find anything. Then there will be a demand for you to make a class. Then the students will start participating in your class. Then the students will say that this man or this sir delivers such unique things which I cannot find in internet. Again, before closing down this video, I will tell you that this is very difficult because our own orientation process, our own thinking, our own way of life is totally from this laptop, this internet, this Google. Question is that can we have an original thinking? Can we make original videos? Can we deliver a class which cannot be found over internet? Then you are a successful teacher, I'm a successful teacher, and the students will be successful in their nearby future. So that's all I wanted to tell you in this video. It is very difficult. I understand that talking over videos and giving those typical routes and paths which you need to follow. But just to wrap up with this one is that remember that you don't need, so the question is that if I don't score 100 out of 100 and if I don't score first division, I cannot become a mathematics teacher. Wrong. You can very well become a good mathematics teacher if you score 40 out of 100. Because that 60 marks which you have not scored, you really know what are the problems you have done in 60 marks, and thereby you can secure a student to get 100 out of 100 now. You should understand the pain of the students because it doesn't matter who you are, right? It is what it matters. I go to a doctor and the doctor gives a medicine, I am happy and I am cured. So you should understand the pain of the students. And I would say a good teacher need not to be a great academician or a great mathematician. Give the time the students to struggle for the teacher and for the parents. This is my message. You are not the key to the answer. It is not that you need to know everything. Come on, no. Let us find out together what could be the solution. And when you do that, you make mathematics as an adventure. Please do not say it is difficult, it is wrong, or I would say it is extremely hard to understand. You should say it needs more practice. Let us work together. So why? Because to a student, English, mathematics, physics, chemistry, at one point it is the same. If you make things difficult, it is a difficult subject. If you make things happy, they are happy. And try to give them something which internet cannot give. Get an original thinking in terms of lesson plans, methods of teaching and videos. That is all what I wanted to tell you. I wish you all the best in order to become a mathematics teacher. And if you think that some of my points have come to use in your career, because many of my students have been benefited, I'm not boasting myself, but they have been benefited by my words of advice or suggestions, please do let me know in the comment box. Please do subscribe for this channel to get all the updates and notification from Physics for Students. And this is Shaunak signing off from today's video, wishing you all the best to become a mathematics teacher and promising you to come again with a very, very interesting video on physics and mathematics. Till then, goodbye, best wishes, and wishing you all the best.
Now, you can be a part of our team. You can send your scientific articles, essays, research papers, lesson plans on a particular subject of science. For further details, please write to us at editor@physicsforstudents.com. Stay safe and happy.